She's here. It's all good. Jack's online. Hello, Jack. You good. You can just wait till she gets here. You're fine. Just watch for the hot stuff there. Okay, I'm coming on over. Hold on a second here. Oh, this one.
You're thinking this one was number 3.
Yeah, that one was the travertine, right? That was a marble, kind of marble. It's really cool, isn't it? I used to have travertine backsplash. Bye, Mitchell.
Hi.
See you in 3 weeks. Okay, let me get my laptop up and we're good to go. iPad, sorry. Oh, Cal, did you get your money? Yeah, you did. You got a quarter. Good job. All right. Switch this out. Hey, Jack. Jackson here. Jackson in the screen. He's in the computer. Jackson the Matrix. Come on.
Wake up, Jack.
Wake up, Jack. Come out and see
Jack,
us.
wake up.
Wake
up.
Wake up.
Wake up.
Jack, I'm gonna steal a chair.
Jack, wake up. Jack, he stole the chair.
Jack, I coach children with chairs.
Jack, funny. Jack,
Somebody told him to take a chair and he did.
There you go. Hey. Hello, everyone. Okay, cool. Here we are. Here we are. We switch this out and I'm good. One more. I have 2 cheese sticks for lunch. Probably because I referenced them in my email last week. Okay. Not gonna need the dog. Was that entertaining at least? Meat lab takes forever for water to boil. I was telling Drew because his never quite got to boil. What happens with those particular hot plates is if you tell them to get to a certain temperature, I think in chemistry, I needed to heat something to 84 or some random thing like that. So you can set it, but it'll go above it and below it and above it and below it. And it'll do that until it settles. And some of them, it takes longer than others. They aren't the world's most high-end, hot plates, but they're good. They do what we need them to do. All right, so we are starting metamorphic and sedimentary rocks. And this will be the last bit on rocks for us. Cool. All right, so let's see. Go, move. Here we go. So sedimentary rocks, you guys had 4 different kinds of sedimentary rock over here. And you know that there's different types, and we'll be getting into the different types. But first we need to talk about how we get sedimentary rock to begin with. So there are a series of steps here. And this is going to be one of those where you're going to kind of want to stick them in your brain forever because these series of steps go in this particular order. But there's one little change in there, one little branch to our series of steps. So weathering. So weathering is the breaking down into sediment. So you got rocks, they break down into sediment. That process is weathering. Are you good? She here? Bye, see you later. All right, so there are lots of ways that weathering can happen. We've got chemical weathering, and chemical weathering is when you have things like water that disintegrates rock, wears it away slowly. Basically, it's taking the chemicals in the rock and putting them in solution with water. Oxidation, you guys know what that is. That's when you get rust, for example, on metals. Same thing can happen with some rocks. Carbonation, and that's mainly marble and limestone. And that's when you get carbonic acid, which is a weak acid that's formed when carbon dioxide dissolves into rainwater. Okay, so when you had that little piece of surprise limestone up there today, I love this dude. He is so 70s looking. That's why I cut the video ahead because that guy's hilarious. So that limestone, you guys put a strong acid on it and you saw it turn into a gas, right? And there was some solid left behind. If you had taken a really close look at that rock, you would have seen there's actually a little bit of dissolving going on where you can see kind of breaking off. So we'll talk about carbonic acid in a minute and how it particularly affects limestone, and next week even more. So we're just gonna kind of gloss over it now. There's a little more rock stuff next week, I guess, but it's not like type of rock so much. It's more about how forces on Earth affect the rocks. So then we've also got chemical weathering by living things. So a good example would be some trees have chemicals in their roots that help dissolve rocks so they can spread out. And then we have acid rain, and this goes back to carbonation, kind of the same thing. So, so acid rain, everybody heard of acid rain before? It's like a thing, oh no, the acid rain. So acid rain can happen with or without industrial influence. So when fossil fuels are burned, as it mentions here, it can send different gases into the air, nitrogen, sulfur, carbon, that sort of thing. We get a lot of carbon dioxide when we're burning fossil fuels. That's why people get concerned about the environment and air pollution. That's all part of the same package, all right? So when you get these gases in the air and you've got rain coming down through the air, those gases, the chemicals in the gases can actually dissolve into the water droplets. And then when the water droplets hit the ground, if it's rain coming out of a cloud and it evaporated into the cloud and now it's coming out, what should the pH of that rain be? Anybody want to give me a guess? 7. Okay, so it's going to be 7. What does 7 on the pH scale mean? If you know, tell me. Piper.
Neutral.
7 is neutral. Perfect. All right, so it should have no acidic or basic tendency. It should be right in the middle. Okay, so as it falls through the sky and it picks up some of these other chemicals on the way down, they dissolve into it. It can turn that raindrop from 7 on the pH scale to something maybe a little lower, because on the pH scale, it's when you go lower, you get more acidic, and then higher, you get what? Yeah.
Or alkaline or basic.
Alkaline or basic is right. Okay, so so 7 is the middle, right? 7 should be water, that should be neutral. What's the highest that we go to for bases, James? 14, right? Okay, so so anything that is between 7 and 14 is basic. The opposite direction is going to be acidic. So when you have this rain now that's more acidic, it hits the ground or it hits structures, it will have a greater tendency to do some dissolving, like we saw with that limestone there. That was a really strong acid. But if you let a really weak acid hit it over time for a long time, you can see the effects, okay? So that's acid rain. There are actually some places where you can see it, like in nature, you can see little pits and stuff that have formed where acid has hit a rock again and again, and it's formed like a little divot or something. And then you can see it on statues and other structures that are outdoors, buildings, you can see it then. So this is so 2 examples of physical or mechanical weathering. So we have chemical, and then we have what we call physical or mechanical. It can be termed either way. You'll hear both, just like basic and alkaline. You'll hear both. All right, so we have freeze thaw. That's the one at the top there. You see freeze thaw? So this is sort of amazing because you think of rocks as being really strong, but water can just straight up crack them if it freezes. So what happens to water when it freezes? Does anybody know where we're going with this, Bailey? It expands. That's where we're going with this. All right, so you get water and it lands in a crack of a rock. It gets cold, the water freezes, it expands, the rock cracks. Okay, when the rock cracks, now the crack is deeper. So next time the water gets in there, it gets even deeper. Okay, and then it freezes and then it expands again. Sooner or later, it just cracks the rock. If you think about, anybody ever use like an awl for breaking up wood? You ever do that? It's like a wedge, and you tap it in and then you hit it with a big hammer or the backside of an axe, and it digs in more and more until it splits the wood. That's exactly what happens with freeze thaw, okay? And then you've got exfoliation, and this is different. This guy down here is showing you a really good example of exfoliation. So exfoliation is when you've got like the outer sheets. It's like little cracks develop in it, but instead of going from the top to the bottom, they go kind of horizontally, if you're thinking of it like level with the earth. So you can see those like sheets that peel off? If you've been to Stone Mountain and walked up it, you've seen it. I've seen it when I'm there. It's like big chunks that are coming off in sheets, right? So that's exfoliation. How do we use the word exfoliation for anything in our personal lives? Lily. Skincare. What are you doing when you exfoliate your face, Lily? Not hydrating it. Think about the rocks. What happens here? So what are you doing when you exfoliate it? Do you want to guess? Chloe, you want to guess?
Removing dirt.
removing dirt, and Drew,
Softening it, like breaking it down so that it's.
Getting there?
sandpaper, right?
getting there, James. You're removing the outer layer, yeah. You got dead skin cells on top. You're supposed to, they protect you, right? But if you exfoliate it, you're scrubbing all those outer layers off your skin. And that's what exfoliating is. And then they do it with feet too. And we use pumice from rocks, right? So that's one way we can do it. So exfoliation can be a consequence of the reduction in pressure during uplift and erosion. So we're going to talk about Stone Mountain a little bit. And if you think about it, Stone Mountain has been uplifted as the ground around it has eroded, and then you get exfoliation. So there's less pressure on the rock. The particles within it are kind of loosening up a bit, and then they're shearing off. So that makes sense when you think about it like that. So we had weathering, right? Weathering broke it down into sediment, okay? Now we have erosion. Now erosion is when you're gonna take the sediment and you're gonna remove it and take it somewhere else. You're not dropping it, you're just removing it and transporting it, okay? So what happens with erosion is, again, you have some different forces at play here. So here are our different forces, or wind is one of them, okay? So wind is one of our forces, and wind is, you could think about it, there are different types of wind erosion. So you've got surface creep, and that's when you've got big particles that kind of blow across. So if you've ever seen, like, even just been outside and seen a strong wind kind of blow across the ground and it moves some little particles, or when you see, if you've ever been at the beach and had the wind blow and have the sand kind of move. So that's surface creep. It's just creeping. It's just creeping along. It's going slow, no big deal. Saltation. This is a good one. Anybody know what that first part of that word? We see salt in there. Do you know, Alex?
It's ions, two or more ions combined.
That's a salt. Yep, that is a salt. A salt. What being a salt is illegal. So yeah, that would be one kind of salt. But when you see salt as part of a word like this, it means something else. So in this case, the word is saltation. Another one would be saltatory. So in this case, how about a salto? Anybody know what a salto is? I see the hand. What is it? It's a flip. What do you have to do to flip first? Yeah, bingo, jump. Salt is jump. That's what it is. So you would say, and this will be in your lesson again next week to remind you, but a salto is a flip that requires you to, like, that's like a punch, isn't it? Like a punch first, punch jumper. Drew, James, somebody help me.
Like you can say you punch.
Yeah, okay, so yeah, so you gotta jump to get into the flip, basically, a salto. So then also, kangaroos and rabbits and crickets and grasshoppers, they all move by saltatory movement. There's all kinds of ways to describe types of locomotion. Saltatory movement is one. All right, and then you've got suspension. So this is when your particles are super tiny, and they're so super tiny that they get completely caught up in the air. So this is your dust storms and your sandstorms where they're gone, right? They're way up high. So when you get stuff like that going on, you can imagine, like, that's not fun to be around. I've never been in a dust storm. I've seen enough pictures of them. I don't want to be in one. And sandstorms are apparently super painful.
Yeah.
Because talk about exfoliation. That's like involuntary exfoliation of every inch of your body that's exposed.
You're getting sandblasted to death from.
What'd you say, Lily? Sorry? Yeah. Yeah. Mm-hmm. Why does that happen there more than here? Because there's sand, right? And what's different about, what do you suppose, Lily, is different about that climate? It's drier. So because it's drier, those particles of soil, sand is a soil, are not held together by grass, for example, like we have here. And because they're not held together, they just blow away. Yes, true.
I was gonna say that kind of stuff also happens at Blue Angel and Thunderbird shows.
Mhm.
Fly really low.
Mm-hmm.
The air can move the sand really fast.
Yeah, it moves everything around. Uh-huh.
It also helps that we have clay here, which isn't gonna turn into
Yeah.
particles like that.
Now, if you get clay nice and dry and you scuff up the top of it enough, like if you had a trail or something that people walked on and you had sediment on the sides, that'll blow. So you got wind erosion, and these are the different types of it. Now you got water erosion. So wind, water, these are our physical kind. So water, you got a bunch of different types. You got sheet erosion. So that's when you got like a thin layer of soils coming off a large area. That's like if you have a hill, it rains, everything just kind of slides down to the bottom. You got splash erosion, which is exactly what it sounds like. Water drip, drip, drip. You ever seen, like, sometimes there are rock formations around caves or waterfalls where you've got water that drips or hits or splashes constantly, and the rocks below have changed shape because of that. Coastal and wave erosion makes perfect sense. That's what's going on there at the top. Ooh, that's fun. That's when you've got waves crashing into the shore and they completely change the way that the shoreline looks. Like, they can change the whole shoreline, and they do. Even here, it's not wave erosion, but it's just the river has changed the shape of our backyard. And we used to have a beach, an actual beach. We don't have it anymore. So then this next part, we're really going to go over next week about rill and gully. So this is going to, when you get to them next week, they're going to be ones that you're going to want to like keep in your head forever. So a rill, and you've probably seen it. You have a big area, all right, and the water cuts this little channel like that wide, and it cuts this little channel through it. It's really obvious if you have like a mound of dirt at a construction site, and you'll see it almost looks like cracks. Has a little, have you seen that before? Little tiny channel. It's not very deep, maybe, yay, that wide, going all the way down, looks like a miniature river. That's a rill. If the water keeps sitting that same area, it's going to erode it more, and it's going to get deeper and wider. That's a gully. If that continues, it becomes a stream, then it becomes a river. So that the evolution is, you know, rill, gully, stream, river. So those are kinds to keep in mind here. And then we have ephemeral erosion. So this is when you create natural drainage ways that form in the same location after repeated runoff events. So if you've got like a backyard like mine, for example, where you've got a lot of different topography, we've got all these ups and downs. You may have noticed some of you got caught in it last time we went down there, but over here, there's kind of a big slope down that kind of goes all that way. There's some cut trees in it at the moment. I think some of you may have gotten tangled in that, but that is an example of ephemeral erosion. It's kind of made its path. It may not have been any little tiny storm that did it. It may have been huge storms, you know, decades ago or whatever, but that's over time that's formed that way. And then tunnel. So this is when it happens underground. So this is partly part of the process for getting stuff like caves. So you have to think back to your acid rain. Okay, we talked about it dissolving rocks. The other thing it does is it hits the ground, water soaks in, right? And you got bedrock. Say your bedrock is limestone. We just saw what happens with acid and limestone. So what's going to happen underground?
It gets dissolved.
It's going to dissolve the bedrock underground, right? Okay, so then you end up with a big hole or a cavern or a tunnel, depending on the density of the rock, the type of rock. It may be able to cut a tunnel through and come out somewhere else. That happens. And there's also, like, you may have seen little springs and stuff that just pop up like out of the side of a mountain or whatever. You've got some tunnel erosion going on there. And it's really kind of cool. Has anybody ever been to a limestone cavern or cave? Anybody ever been to one? Like Ruby Falls or Luray Caverns or any of that? You been to Ruby Falls? What's it look like in there, Sky? Like, describe it.
I don't know, all of the rocks are really smooth.
Mm-hmm. They're really smooth. Mm-hmm. And are they like, is it a bunch of like little round rocks, or what kind of shapes did you see? Like,
They're like all bigger rocks.
Mhm.
And they're usually like, they were mainly oval shape, but there's a bunch of them that are from like the ceiling.
what do we call the ones that form on the ceiling? Anybody know? What? Yeah. How do you know the difference between a stalagmite and a stalactite, Bailey? They hold on tight. That's it. You got it. Stalactites hold on tight. Those are the ones that come from the top and down. And we're going to talk more about that stuff. Sorry.
You might step on.
Oh, yeah, there you go. You might step on them. I never heard that. That's a good one. You might step on them. I like that.
Or like X might get shoved off a cliff onto one and be.
Or you might,
by it.
you might get shoved off a cliff. Yeah, okay.
It isn't.
So when you, another type, there you go. Okay, so this is gravity or mass movement. All right, we're going to talk a lot about mass movement. Your next two lessons have a lot of mass movement in them. So mass movement is stuff like rock falls, mud flows, landslides, rotational slips and slumps. There's also lahars, all kinds of different ones. So you've got rock falls. That's pretty obvious. If you are driving through the mountains, there are these little signs, they're they're yellow and black. You see them, what do they say? What do they say, Alex?
It's like rockfall warning,
Yeah,
rock lights.
yeah, it says
Yeah.
like, watch for falling rocks usually. So, that's because they will erode right off the mountain, gravity will pull them down and they'll smack down the road, or they'll land in the middle of the road. So say like, watch for fallen rock. Yeah,
I saw a picture of a sign that was kind of like that,
uh-huh.
but there were rocks and a cow falling.
Oh, yeah, I've seen that. Rocks and a cow. Oh,
Or,
yeah.
like, how many times do you have to see that before putting that on the sign?
Yeah.
Where are the cows coming from if there's been enough incidents of cows falling from the?
Yeah, so a lot of the times they'll say, watch for fallen rock. And the idea is that you could come around a corner on a mountain road and there'll be just a rock in the middle of the road, big rock. You want to be careful for that. When I was little, though, I'll tell you, because this is one of my favorite weird childhood things. When I was little, I asked my parents what those signs meant. So we would sometimes drive up to the mountains, which weren't too far from Virginia Beach. You just go kind of west and you hit the Blue Ridge, right? That's kind of the middle of the Blue Ridge, whereas it starts down here, right? And I asked my dad what those signs meant when I was like 4. I was like, what do these fallen rock signs mean? And he said, tell me this whole story about this Native American brave and this, he used to make up the best stories. And this girl, and her name was Fallen Rock, and she ran off because her dad wouldn't let her be with him. This whole like traditional, the kind of story you hear, kind of like the Saltina Coochie one that we have up here. It's a local legend up here. Never been up there. You should check it out. It's cool. But a whole thing about how she's still running and you don't want to run over her spirit in the road is what he told me, which might have terrified somebody, but I thought it was pretty fascinating. So mud flows and mudslides are exactly what they sound like. You get enough water and it comes flowing down slope. And these, unfortunately, these hit California fairly often. I don't know why. I don't know why people live there. They have earthquakes, they have mud flows, they have all kinds of crazy stuff. But several years ago, I cannot remember what celebrity it was. It wasn't Oprah. It was somebody really big. And a mud flow just poured right into the house, like filled the whole house, the backyard, everything. There were pictures of it. It was a disaster. Similar to a mud flow is a lahar, and that is caused by a volcanic eruption. And you get all the ash mixed in, and that can just like, there are towns that just get completely taken over, especially island towns where there's active volcanoes, like out in the ocean, you know, they get completely flooded and it's gross.
Lahars get going at like hundreds of miles an hour.
They go fast, yeah.
And they're also incredibly hot and incredibly heavy, so they could just take out the
They
entire
level it,
town,
yeah, they are
burn
heavy.
everything in its way, salt the ground, just make it so
Yep,
nothing.
salt the earth, we're
ever
done,
needs
start
to
over.
grow.
Yeah, exactly. Landslides are exactly what they sound like, and I don't know why these things won't go. They're making me crazy here. Stop spinning, that's annoying. Stop. Nope, it's not gonna do it. Anyway, so landslides are exactly what they sound like. You got a big chunk of land and it just lets loose and goes, just there it goes. And then lastly, you've got rotational slips and slumps. And this is when you can see, like, it almost looks like, you ever take, like, if you take a piece of clay and you just push it forward with your palm and you see kind of like this wrinkle and a bump, it's like that, and just gravity affected. So it comes down and you get this like bump, where it kind of moved from underneath, but it didn't fall off and roll down, if that makes any sense. But we'll see some examples of some of that when we start talking about it more next week. So glacier erosion, that's another thing. So we had wind, water, gravity, glacier. These are our mechanical types of weathering. So in this case, we've got movement of chunks of packed ice causes erosion underlying the glacier. So this is you can see a little time clicker down there. Shows you where it started, where it is now. So you can see that glacier move. They don't move fast. They move really, really slowly. But as they go, they have two processes at work where erosion is concerned. And again, these will get addressed again next week, but it's plucking and abrasion. And plucking makes it sound like it's like, oh, pluck the flower gently. They're not very gentle because they're huge and they're heavy, right? So they come across the ground and there are rocks, entire boulders, huge things. And as they approach them, they freeze right into the bottom of the glacier. I mean, you could do it if you had a really cold piece of countertop and you had an ice cube, you could stick it on and put something underneath, something little, you could stick it, make it stick. You ever done that with ice? Like even with snowballs, you can do that. You can, you roll it through the yard, you can pick up sticks and things, right? If you're making a snowman, you get sticks and grass and dirt, and all kinds of stuff in it. That's the idea of plucking. But then it sits there inside the ice and it just rolls along. And somewhere it gets dropped off, and it gets dropped off either when the glacier melts, or maybe it hits a turn and some things get left on the side. And when we talk about glacier movement more in the future, there are all kinds of processes that work for, like, if it rolls down into a place and then just melts and it leaves like a puddle of stuff that it took, you can find rock in one place that is supposed to be hundreds of miles somewhere else because it got moved by the glacier. The other thing, abrasion, so you've got these plucked rocks, right? Got these boulders and rocks and big things stuck to the bottom of this giant heavy piece of ice. And as it rolls along, those guys on the bottom scratch everything underneath. So if you're going over a rock, that's maybe a big piece of rock and it's somewhat exposed, but it's not big enough, it's too big to come up out of the land. All those little sharp rocks, heavy rocks, are on the bottom of that big glacier, and it just scratches. And there are places you can see big giant scratch marks in rocks where glaciers rolled over them. So it's just like, but it's doing it to rock. It's pretty neat, actually. It's really neat when you see it. The pictures are cool. So we had erosion, which was what types? Just went through the types. Drew?
So there's gravitational, there's water, there's wind, there's glacier, and
That's it. Wind, water, ice or glacier, and gravity. Okay, these are your four things that cause erosion. Now, first we had weathering. Weathering is what? Define it. Alex?
Gradual breaking down and removal.
Not remove. You have to stop there at weathering. Weathering is the breakdown into sediment. Full stop. Then what's erosion?
Movement is included.
Picking up and moving. Okay, so you start with weathering, you break it down. Then erosion, you pick it up and you move it. Now we're moving. We're gonna hold on to it forever. We're gonna have to drop it. So do you see the word deposit in the word deposition? We're gonna deposit it somewhere, right? Can't hang on to it forever, especially if it's wind. Think about it. You got sand, it's not gonna stay there. Thank God. That would be bad. So you got
Gotta deposit to the riverbank.
yeah, somewhere. So you got rock fragments that are deposited on the ground or sink in water. Now that's another thing with suspension. Okay, it talked about suspension with air. It didn't really talk about suspension with water, but that's totally a thing. And when we get to streams and we talk about stream beds and river beds and like the layers of rivers and things, as they flow, particles get suspended in that fluid too. Fluid is fluid, whether it's water or air, very similar behavior, right? Physically. So you've got all kinds of things that get caught up in the suspended liquid and then land somewhere else, basically. And if it's a really fast river, you can get bigger pieces because it's a stronger flow. And it's a slow river, you'll get nice little silty stuff, right? So we've got different kinds of deposition, obviously. So we had our erosion, which was wind, water, ice, and gravity. And then we had, well, that was our weathering, wind, water, ice, gravity. And then our erosion was also wind, water, ice, and gravity. Those same four for those two. Now with deposition, it's pretty much kind of all gravity based, but you'll see. So you've got the size of the particles that are going to depend on how they're transported, right? And where they land. So deposition is the dropping of sediment by wind, water, ice, or gravity. And then sediment is, so we have it again, wind, water, ice, gravity. Go figure. Wind, water, ice, gravity is erosion. Sorry, weathering, erosion, and deposition, right? So that's easy to remember. You can keep all three of those in your head because you know you have a test coming up, right? Yeah, you do. So sediment's created through the process of weathering, carried away through the process of erosion, and then deposited in a new location by deposition. So you can see right here is an example of that sand getting moved back and forth right on the beach. That's getting deposited differently. So now we're getting to how we get a sedimentary rock. Now we have this process, lithification. This is when your sediment is going to become rock. So it's been weathered, it's been moved, it's been dropped, and now it has to become a rock. So if you see that lith, does anybody know another word that has that in it? Alex knows one. What you got?
Lithography.
What's lithography?
I believe it was like
thank you,
taking pictures on stone plates.
Yeah, lithograph. Very good. Okay. Anybody else hear lith ever? I've heard of a monolith. Oh, yeah. So that's stone when you see it. Here's a fun one for you. You ever heard of a tonsil lith? Ooh. Yeah, you heard of it?
Is that a tonsil stone?
Yeah, so if you have particularly, they call them, was he out there? Oh, cryptic tonsils, tonsils with lots of like pits in them, stuff gets stuck and other stuff comes in and they make these little stinky balls. A lot of people get that, it's tonsillous. They're totally normal, but they're kind of weird. So lithification is when your sediment becomes rock. All right, so how does that happen? Is it gonna be wind, water, ice, and gravity again? Do you think? That's been everything else so far. So it's not, we're actually gonna have something different this time. So we have compaction and cementation. So these are our two. So we started, everything else was wind, water, ice, gravity. This is gonna be different,
Technically, aren't both compaction, at the very least, compaction, isn't that also by
Gravity,
gravity?
yeah. Gravity's kind of all of it to a degree. When you think about it, most of these things are gravity controlled. But they try to kind of break out the ones that are kind of only gravity, like falling. So compaction, this is when you get your sediments together and they get squeezed. Now, what would make them squeeze together? Piper.
A lot of force,
Yep, where's it coming from, do you think?
gravity.
Gravity, okay, so if I had sediment on the ground, just laying there on the ground, what is gonna cause it to have that kind of pressure on it? What do you think? Bailey?
Something to put on it.
Yeah, something put on it. So as it layers, all right, so think about it, you got sediment, more sediment on top, more sediment forms on top. As it gets pushed down deeper and deeper, the mass above it is, you know, heavier and heavier. Gravity is really affecting it. The stuff at the bottom starts to get squashed. And as it gets pressed together, you get compaction. And also it tends to kind of work so that the smaller pieces fill up the gaps, but then you're still going to have some gaps. And that's where cementation comes in. So you'll have a dissolved mineral, usually a crystal mineral, and it'll be in solution like we had today, right? And it'll fill in all the cracks, and that's like a glue, and it holds it all together. So dissolved mineral crystals will hold it all together. Yeah, they're doing something with it, cooking these things to show you an example of, oh, let's pull this
Wait.
together. Yeah,
Is that grapes?
those are grapes. Yeah,
Corn flour?
I don't remember what that was. I don't know. It was
Cocaine. Yes.
cementation. They're making cement. They're gonna smash stuff together. I don't know. People do weird things,
They're
but
making cement out of grapes.
so how do we recognize our sedimentary rocks? All right, so we got to recognize them somehow. So there are some ways that we can tell what they are, like we did with igneous rocks, right? So you got bedding. So which of these images do you think is bedding? That's layering. Drew?
The top right.
The top right, that is correct. That is bedding. So in layers. So it formed in layers, right? You got a layer, it forms. A little while later, you get another layer that forms. So how about graded bedding? Anybody want to guess that one? Liam, what you got?
That one right there, next.
Top, bottom, right, left,
Bottom,
bottom.
left, one to the right.
This one here?
Yeah.
Yep, that's graded bedding. So graded bedding, you look there, those particles at the bottom, they're bigger, they have more mass, they go to the bottom. The lighter, less mass particles go to the top. So that's graded bedding. It's graded, like ranked, basically. You can think of it like that. So then cross bedding, what's cross bedding, do you think, Chloe?
The pinkish looking one.
Yes, the pinkish looking one. So what would have to happen to create that situation? What do you think, Piper?
Either change of magnetic pole.
Wind could do it. Yep, the wind coming from different directions. Yeah, definitely if you had a switch in the poles, which when we get to that, that's like one of my favorite lessons. When you talk about magnetic pole switches in the past, there are ways to prove it, and it's super freaking cool. What else could cause that? Do you think, Bailey?
Water.
Water could cause it? Yeah, that's true. What do you think, Alex?
300,000 bulldozers working in
Concert with one another?
Yes.
Okay,
Very
yeah,
specific.
sure. Yeah, that is very specific. Okay, so those are some ways.
Ooh, people with rakes.
Another way it might happen is, okay, say you have an area with a fair amount of seismic activity or some force that causes the land to shift around, and you had a rock and it was like this and stuff landed on it, and then the rock got shifted like this, and then you got stuff, and then the rock got shifted like this, and it got shifted like this. You would see the effect of gravity with how things are layered. So then when you flip it around, you'll get something like the cross bedding, which is kind of cool. And then the ripple marks, obviously, those are these, right? And that's where the waves, you can see wave action in the past. There's been wave action there. And then sorting, we're getting down to the last couple. So this one down here is an example of sorting. Do you guys know what kind of rock that is? Chloe?
Plastic.
It's clastic, that's right. Yeah, do you know what kind of plastic rock it is? Alex, do you know?
Conglomerate.
It's conglomerate, yeah, it's one of my favorites because it really sticks out, it's easy to see. And you'll see it in a minute when we go to that page. So last one is fossils. You're only going to find fossils in sedimentary rock. Doesn't make sense for them to be in igneous rock, right? And if they're in metamorphic rock, they would have undergone such heat and pressure that chemical composition and stuff is going to start to change. So you're only going to find stuff like this in your sedimentary rock. And it's really cool. So clastic, this is what Chloe said. So clastic sedimentary rocks. So we've got different types. We know that there's chemical, right? And we know that there's organic or biochemical because we saw those in labs. So clastic are ones like these. So clastic are the ones you find in more loose sediment that get compacted over time. They're more affected by the compaction and cementation, obviously, than these guys, these chemical ones. Chemical ones are just evaporates and there they are, or you get a chemical reaction and there they are. But then that reaction you usually have to have, like that when we did the silver nitrate in the salt, you got that little bit of sediment that fell down, that precipitate, you'd have to have a lot of that, and then you would have to have some compaction to make it actually form a stone. So you got coarse grained, and your examples here are conglomerate and breccia. This one's breccia. It's pretty cool, this one. And that's conglomerate, which we just talked about. And I think I mentioned before that sometimes they call it pudding stone, especially up by Lake Michigan. That's just like a thing. There are people that collect pudding stone. If you go on YouTube and look up pudding stone videos, there's one dude who has, like, no joke, he has pudding stones like lining his whole yard, big ones, like big ones. And they line his whole yard and he's got them everywhere and he shines them all up and they're really pretty. And there's another guy on there who cut them. He's got a, what do they call it? The saw, it's a special kind, it has lith in it. I don't know, it's kind of blade, I can't remember what it's called, but it's intended for rocks. And he'll slice them really thin and you can see all the different rocks inside. It's really kind of cool. And then you got your medium grain one. And this is like your sandstone and that sort of thing, where you, like right here, where you can see the grains, but they're itty bitty. And then you got your fine grain, and that's your silt and siltstone and clay. So like our red clay, it's going to form one of these like fine grain ones over time if it gets compressed enough. It's not going to do that. Now it could fill in the middle, could absolutely fill in the middle, but it's not, obviously can't do that because that's not how it looks. So these are the chemical and biochemical / organic, call them whatever you want. Oh, by the way, what's this picture? Do you know what that is? Anybody know? Anybody know? Ooh, Piper, what is it?
Something in Utah. I think.
Yeah, it's out in Utah. They have in Texas. Drew, you go.
Salt Lake.
So, yeah, Salt Lake, it used to be. Do you know what they call it now, Liam?
Great Salt Lake.
No, it's not Salt Lake. They call it, you know? There we go, Salt Flats. Okay, Salt Flats. So that's what they call them. And this is where, if you've ever watched, you ever watched the people that do racing on them? So if they've had rocket cars and things like that, that they've tested that go super fast, but they also have to go a really long way. And they'll test them out there on the salt flats because it's level and it goes on for, as you can tell, for a long time. And they put those rocket cars on there because they have tons of room to move and not smack into anything else. So you've got your chemical and biochemical. This is pretty obvious. Chemical stuff comes, it's evaporites or sediment. It's exactly what you did in lab. So you had precipitate or you had evaporite, but in any case, you made chemical sedimentary rocks. And biochemical contains the remains of once living organisms. Limestone's an example. Chalk. Chalk's a great example. What's chalk made of? Anybody know? Do you know, James? Do you know where it came from? Yeah. Do you know what dead things? A lot of it is whatever was at the bottom of an ocean. So it's like, it can be mollusk stuff, but it also tends to be a lot of like diatom, phytoplankton, all that junk gets crushed down into the bottom after years and years and years. And, you know, if the water goes away somewhere else, because we've had oceans all over the place, right? And it changed position many times. That's where you get chalk. So chalk's a great example of a biochemical rock, and limestone as well. And these, see these, this right here, this looks like something out of, what's that movie called? That James Cameron movie, Avatar. It reminds me of that. And these are limestone cliffs that have changed over time. And then also, I didn't mean to click that yet. These are salt rocks that form at the edge of like a salt lake or a salt lagoon. And if it evaporates enough, you get these big chunks of salt like that. It's kind of cool. It's really pretty. So metamorphic, and you guys know bio means life, right? So it's biochemical, it's chemicals from living things. So metamorphic, and then you have this definition of metamorphic, and it said what? Meta is change, morph is form. Rocks that change form. Metamorphic, right? So metamorphic rocks are the ones that undergo a lot of heat and pressure. Now, so if we think back for a minute, we had weathering, which led to what?
Erosion.
Erosion, which led to what? Deposition, which led to, Liam again.
Lithification.
Yeah, by what? What two things happen for lithification?
Cementation.
Yeah,
And
and
compaction.
compaction, bingo. All right, great. So now you have a sedimentary rock. And if you put that sedimentary rock under intense heat and pressure, you have a metamorphic rock. But you have to remember, an igneous rock can do this too. Okay, so if you have an igneous rock, it can undergo intense heat and pressure and it can become a metamorphic rock as well. It doesn't have to be a sedimentary rock. Okay, so they get super hot. There's a lot of heat, there's a lot of pressure, but they don't become magma. They don't melt. All right. So they change into other minerals that are more stable at different temperatures. So certain chemical compounds are going to be more stable at certain temperatures than others. That gets really complicated. It gets into a whole lot of chemistry. So when you have that going on, you can change there's actual chemical change that occurs due to intense heat. Like we saw with that limestone, we heated it up, right? And there was actually a chemical change because we saw a change in color. It wasn't just a change in form, right? It wasn't a physical change, it was a chemical change. It was actually decomposition, which is one type of chemical reaction. When we get into chemistry, there's a bunch of them, but decomposition is one. And that's what happened with the limestone. So in this case, you've got these minerals that are going through this process of increasing heat and pressure. And yeah, he loves that perch. He's just gonna sit there and think he's the king of the world.
Right there.
Yep, he loves that right there. He's looking at you like, hi, you know, you want to scratch my head. So, for example, you can get shale that turns into slate, that turns into phyllite, that turns into schist, that turns into gneiss over time. And that's exactly how it happens over time. It's kind of cool. So what are some textures of metamorphic rocks? What are some ways that you can identify them? All right, so, well, first let's get to the page. So you've got mainly foliated and non-foliated. So foliated, what does that sound like? Do you recognize that word? Sound familiar to anything? Piper, do you think?
Foliage,
Foliage, what's foliage? Bailey?
does leaves or other things on the ground under.
I thought foliage was leaves on the tree.
Yeah, those.
Right, it's leaves. Foliage is leaves on the tree. Nobody dropped any food. She's not getting food out of her bag for you, for real?
I put it away.
Okay, so anyway, that's foliage, so leaves, and you can think of it as leaves. I tend to think of it like, anybody ever made like a layered pastry or worked with dough, like phyllo dough? That's a similar word too, isn't it? You worked with it, Bailey?
They layer cakes.
Yeah, kind of similar. But if you work with like the dough that makes croissants or puff pastry,
Oh, yes.
so it's layers and layers, they put butter in between them, and if you squash it around, it'll do just like that, which is exactly what happens here. Your pressure is gonna come at different angles. And as it comes at different angles like that, it'll be perpendicular or horizontal to whatever axis. You've got an axis, right? You got one this way and one this way, you got an X and a Y, X axis, Y axis, two axes, right? And they're sitting there like this, and the pressure can come at them from different angles depending on the position of the rock, what else is going on around it. And you end up with this cool wrinkly thing. It's really cool. It's really, really neat. I mean, that's cool. So you can end up with that. And then your non-foliated, it doesn't fold like that, but you get these like blocky crystal chunks, and then you can get protoplasts, which are like large mineral crystals. A great example is marble. So these are marble cliffs actually. And if you have like a marble counter in your kitchen or whatever, you can look at it. You might see big chunks of mineral crystal in it. Those are your protoplasts. There's some cool stuff about marble too that we'll talk about in a minute. So your metamorphic rocks there's grades of them. We have grades of metamorphic rocks. So this is another way we can categorize them. So we can categorize them. We just did how they were formed, right? Here's another way. So low grade, intermediate grade, and high grade. So this is where we're talking about low grade stuff is low temperature and pressure, things like shale. right? And then intermediate, you got your like slate, phyllite, schist, and it starts to move to higher grade, which is the gneiss. And this makes sense, right? Low to high, pressure is low to high. There's nothing really fancy about that. So just be aware that sometimes they will categorize rocks just like that as low grade or high grade. Oh my goodness, God, this dog has no shame. So types of metamorphic rock. Okay, what are some types? So we talked about foliated and non-foliated. Now there's also regional and then contact. So regional is when you've got large areas that are affected. Like there was lots of heat and lots of pressure in one particular area for a long time.
There's a brownie point.
Yeah.
Come into contact with.
There you go. We weren't even there yet and you found it. Okay. So metamorphic rocks are created when your molten material comes in contact with, thank you, Alex, you caught it. I never even saw that one, with solid rock. Okay, so think about that. You've got solid rock and you've got magma that's coming in contact with it, but that solid rock's not melting yet. Kind of right on that edge, but it's experiencing the intense heat that comes from the magma that's not going to come from anywhere else. It's super, super hot, right? So then you can get some changes in those rocks. So you can categorize them this way too, regional or contact metamorphic. So what are some economic impacts? What do we use these rocks for? All right, so yeah.
Building things.
Building things, yeah, there you go. So first off, we've got metallic resources. So you can often find your metal ores in areas where you have a lot of hydrothermal activity. What does hydrothermal mean? Take those roots apart. What's hydro? Somebody give me a hydro. Okay, hand next time. Hydro, right? Water, thermal, Chloe, temperature. So if we're talking about hydrothermal, what does it mean? Drew?
Hot water.
Hot water. Okay. So when you've got some area, and we're talking hot water, we're talking hot water. Oh, daddy's in the kitchen. Daddy's got food. Look at this dog. No shame. So you can often find your metal ores where you've got areas of hydrothermal activity. And if you've got hydrothermal activity, what kind of rocks might you find there? You've got these metamorphic ones. Think about it,
Anything that can be dissolved in water.
Yeah, so you could have some sedimentary rocks too. Exactly, any of the chemical sedimentary rocks. So you can also find your non-metallic. This is your talc, which is like similar to chalk, right? And your asbestos too. Who knows anything about asbestos? You ever heard of asbestos? What do you know, Bailey? Not a mold. Do you know what it is?
It's a type of rock that if you breathe it in, it'll probably kill you.
So have you ever seen the commercials for mesothelioma? Oh, come on, they're always on. If you watch local news, if you have mesothelioma, contact, you worked in the following industries.
Could be owed billions of dollars.
Yeah, okay, so basically, asbestos was used as a component in building materials for a long time. It was used in tile, a lot of it was tiles, walls, things like that. And yeah, insulation, a lot of it in insulation,
Fireproof.
all that, yeah, fireproof materials, so all that kind of stuff. The problem was, if you breathe in the fine particles that you don't know you're breathing in because they're so fine, it's completely carcinogenic, it's cancerous. It can give you mesothelioma, which is a type of lung cancer.
Mesothelioma.
All right, yeah, it's terrible. So probably around the late 70s, early 80s, it became a huge deal to get rid of all the asbestos. So they went into buildings, especially big public buildings where they used like lots of one kind of tile, for example, schools, and they had to rip it all out, gut everything, put it all back together a different way.
The asbestos purge.
Yeah, it went on for a long time because it's not something you're going to be able to do in a day. I mean, not all the building materials in the world are going to come down in a day. You got to replace it, right? So it took a while. I remember there being talk about it, they had to replace some things in my elementary school because there was like, oh, there's asbestos here. Oh, all the kids are here, great. And I actually worked in one of those old houses in Atlanta in Midtown. It was actually a house, but it was my office, and the basement, it was kind of cool. It was a doctor's residence and the basement was his practice. And it was kind of creepy down there because there was like a lab room in there. I loved that, obviously, but they had like pegboards for drying lab glass, and it was creepy. There was a dark room, but that part of the basement was a dirt floor and you had to walk it. I was not going. I was convinced it was not. It was creepy, but all the tile down there was asbestos. So we were told if we had to go down there, we had to limit how long we were there. It was a big thing. And there were days I had to work a whole day down there organizing stuff. So I'm like, breathing up the tiles. Great, fun times. So this video here, this lady is gonna mash some jelly beans to give you an give you an example of how you can get metamorphic rocks. It's a good lesson. It's just a little goofy because she loves to mash the jelly beans. So, but do I not have? Hang on, there it goes. That's fun.
I bet you thought rocks are just rocks, right?
No,
Nope.
these people are ridiculously goofy. It's fun though.
Igneous and metamorphic.
I like him.
But the coolest thing about rocks is that each one has the ability to change into the other kind.
It's ridiculous. It's great.
Sedimentary,
Completely.
metamorphic, and igneous rocks change into each other in a process we call the rock cycle.
Yeah, maybe. I love the rock. Like,
Well, not that kind of.
I giggled the whole time I
Yes.
watched it the first time.
Yeah, that's more like it. Yeah.
These are somebody's science teachers in the school, you know it.
Sedimentary. On the surface of the earth, wind and water break down rock into tiny pieces. Those pieces might collect in a riverbed, on a floodplain, be swept into sand dunes, or collect on the ground. Over time, layers of these rock fragments build up and start to weigh down on one another. Eventually, they get fused together to form sedimentary rocks. The cool thing is that if you look closely, you can still see pieces of the original rocks or sediment that were bound together.
A bunch of tiny dead bodies.
Yeah, there you
Let's do a demo. For our rocks, we're gonna use jelly beans. Each flavor.
I
of
would
jelly
eat the jelly beans personally.
Represents a rock or mineral.
Seems like a
by
waste.
breaking down wind and water through a process called erosion. You put our jelly beans in this bowl and add some honey, and cornstarch. They're the bonding agents to hold our pieces together, kind of like glue for rocks. A little time and pressure has turned our jelly bean pieces of sediment into a brand new rock.
Eat it.
So what happens if you apply both heat and pressure? It becomes a metamorphic rock. Metamorphic rock may form by friction of the Earth's shifting crust, pressure deep within the Earth, or even radioactive decay. The heat and pressure cause the rock structure to change, so it takes on a new form. Even though it's changed, you can often still see structures of its original components.
What was that?
No.
Let's take our sedimentary jelly bean rock and turn it into a metamorphic one with heat and pressure. To add pressure, we'll put this heavy pot on top. For heat, we'll stick it in the oven for about 30 minutes. After it's cooled, you can see how our jelly bean rock has formed a more solid unit. However, you can still see the individual
Very
pieces of candy
sticky.
Look at wasted jelly beans, these people.
fundamentally changed.
The third type of rock
I
in
wouldn't.
the rock cycle is igneous. When rocks get superheated deep within the earth, they melt and form a liquid called magma. If magma rises to the surface or moves up in the earth's crust, it begins to cool. Igneous rocks have a uniform structure throughout, but will have different properties depending on whether they cooled on the earth's surface or within the crust.
To turn our jelly bean metamorphic rock into an igneous rock, we're gonna melt it in a pot of boiling water.
That's gross, man.
When our rock is cool, you can see how all the different pieces combine to make an igneous rock with uniform structure throughout. Pretty cool, huh?
Gross.
But this is only part of the story. We showed you one path of the rock cycle, but really any rock can go from one type to another. For example, igneous rocks can turn into either metamorphic or sedimentary. And metamorphic rocks don't have to become igneous rocks. They can be broken down again and become sedimentary. Or the sedimentary rocks can get pushed deep within the earth to form igneous. See, all of the rock types are connected, making a cycle that never ends. The end.
I'm here.
And
I was so amused by that, though. Oh, yeah. And they do. You know, those are people's science teachers, like the 3 middle school science teachers or something. I mean, for goodness sakes. So we have weathering. All right. Weathering is what? Piper. It's the
Breakdown of rocks with gravity.
into sediment, breakdown of rocks into sediment. Okay, and what does it cause? It can occur by chemical or physical, and it allows for erosion. You can't have erosion really without some weathering. What's erosion? Liam?
The removal and transport of sediment.
Removal and transport of sediment. And when you have erosion, it's wind, water, ice, right? Wind, water, ice, gravity, and it can result in deposition. What's deposition? Who hasn't answered? Milo, what's deposition? Yeah, sure. So it's been weathered and then eroded, and now we have deposition. Ozzy's thinking about it. You know the answer? Nope, sound asleep. Half asleep. Look at the eyes. Did you find it?
No, but I know it's sinking bodies in water and then.
Yeah, that's right. So it's when it either lands in the water and sinks or it lands somewhere else. It's been transported, it's got to get dropped. So deposited, that's the word you're looking for in there, is deposited. And that is going to allow for the sediment to become compacted. Now look here, these are your ones where you have wind, water, ice, gravity, wind, water, ice, gravity, wind, water, ice, gravity for all three of those really, okay? And then you have compaction. Who's got, Parker, do you have compaction? Do you know what compaction is?
Yes.
What is it? What does it mean to compact something? You can think of it. Like a compact car, or to compact it is to what?
Someone could small.
Yeah, so what would it mean if you had something and you had to compact it? It's like squeezing, you got it. It's like squeezing it, pushing it down, making it into something smaller. You're right, the
Like we
small.
did with the jelly bean.
Like she did with the jelly beans. That is compaction. All right, so then once it's compacted, it allows for cementation. And Bailey?
They're binded together.
Yeah, they're glued. They're like glued together. And that's what you get. There you go. That is when you've got a lot of time, it's like the mineral solution. We talked about like dissolved minerals in solution, gets all stuck together. And that's your cementation. And then the last step, when it's all glued together, you have what? Everybody? Lithification. Uh-oh, what do we see? What's at the top corner? Ding, 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 ding. Yep, know this one. Know this one, know this one, know this one. Okay, now, yeah.
Could you say that something that should be written in stone?
Ah, that's great. That's such a bad pun.
This saved my life one day.
It's like a dad joke.
Oh.
Holy. Totally made a dad joke. Wait, what was, I heard a great dad joke the other day. I was gonna say it too, and I can't remember it. Oh, it was super. Okay. So I'm actually going to show you one other video real quick. I forgot to put it in your slideshow, but the juniors had it and it's definitely worth watching. It's this lady with her sandstone. It's really cool. Where'd it go? Come on. So this lady has this chunk of sandstone that she's had for 45 years, and she decides she's going to break it open and see what's in it. And it's actually really kind of neat, but I got to tell you, this lady has the most like perfect Midwestern accent I've ever heard in my life. Like it is stereotypical. Break the sandstone. So breaking grandma's sandstone. No, look at it. Thump, thump, thump. Apparently she used to be an expert at this, because she's done it enough.
It's an ammonite, it's loosening the rock off of the.
So she wants an ammonite. Those are those shells that are spiraled all in, like a little lollipop. That's what she thinks might be in there. If you can hear the pitch of the hammer changes in certain positions on the rock.
So it is hollow, it's hollow. Assuming it's strong.
It's not hollow, it's never hollow.
He's an expert.
It's not how these guys are never hot.
I love her.
We'll stick with that. I think I will.
And
Hopefully.
that is something next.
Well, I always there's a density difference.
That's been hanging on to that for 45 years.
That's really solid there. So there's a density difference.
You can hear it, right? You can hear the difference. She's so good Western the way she talks, it cracks me up.
Put a chisel straight at the head. Actually, looks like a little pretty. That's just funny, but-
Yeah, right. She'll get it. She's very patient.
That's good there. That's solid rock there.
Yeah.
Give us some, ooh,
No, there it goes.
There's a crown, there is a crown. You can chisel it.
so it's coming up here, right along there. You're gonna get like it off like a cap kind of, you might be able to break it twice.
Oh, yeah, well, then you break up all the little pieces and break it.
That's 72.
She's so cute.
So it looks like there's gonna crack.
Yeah, here's where it's coming. Yeah, let's try there.
Like that.
And she's hitting it with the other side of the hammer.
A little tougher here. This is where it's.
This
gonna
is
crack.
so cool.
Gonna crack it. But if you just pull out a whack, whatever's in there is not gonna come out in any shape.
Well, you have 35 years, no rush now, right?
No rush. Yeah. And she's cracking this one too.
Now you can really see it following her hammer down. That's pretty cool. You would be excited. 45 years ago, no one that.
Oh, this is right, that's a nice break. Okay. I'm filming up.
The cracks are old enough now for a picture.
Is it gonna
Oh,
be
where's
right?
that stuff? Why is it doing that? Come on, somebody swore.
No, that used to be a crayfish.
There could be a crayfish in there.
It's not hollow like I thought it would be.
Why does it lag? Don't lag. Why'd you stop?
Right now.
Yeah, right when everything exciting happens. Hold up. Wait. Hold on. Don't do that. Chill out. Come back a little. Yeah, load. Oh, come on. Look, you can see it in the one above it. See it? Jeez.
Yeah, get it sit on there.
Hold on. Let me do this. This makes me crazy.
You really see the picture?
Oh, for goodness sake.
Look up here.
Hold on here.
You're gonna get like it off like a cap.
We're gonna fix it. Wait a minute. Come on. There we go.
Of course, it breaks right now.
Yeah, gonna be stupid right when we're trying to see it. Yeah. Why is my email opening up? You didn't need to read my email to my dad's.
Did you know
Nurse.
this sweet mineral melts in
Yeah,
your mouth to
yeah.
rebuild your gums and teeth
Yeah.
while you sleep,
Move on.
helping you
Okay.
stay goodbye.
I don't want to hear that voice say, "Wow, you sleep."
There it is.
Okay. That was the crayfish.
She's excited.
You see the little black nose on it?
That nice.
Lead it back.
The most good Western accent ever. Hilarious.
Get it spit on there, then you
You just spit on there. Did you see it?
Oh, it wasn't it.
And Cecilia, you're varnishing? You really see the picture there? Where did that go?
Yeah, we need to put this in like a plastic thing, something that's not going to soak it up. You really see the colors coming out now?
That's cool. You can see it there.
Yeah.
Put it in here, so it's out.
You want me to
Varnish it, and it's shiny, and you can see it better than, like when you dip the rock in water, you can see it better. That's pretty cool, though.
Yes,
You can really see it now. The guy stands out from rock. He's still.
This is a joint project.
Hey, 45 years maybe.
I know that I was your rock roll over Southern Alberta.
She's Canadian. There's the accent.
One day, you'll have to look it up in your basement.
So she had it in her basement. Anyway, cool Canadian grandma there, had it in her basement all these years. Very excited. She's cool. So after we get out of that one, nope, go away. You can go away now. Let's go back to yours. So we were here. So please note, pay attention, pay attention. Don't show up next week. I'm not gonna let you in. I'm gonna be here, but I am not gonna let you in. Sorry, love you, you're not coming in. So we have no class next week because it's fall breaks. Forsyth County fall break, so it's our fall break. However, you have to do what? Complete your Unit 2 test. Unit 2 test is still due on the 4th, even though we're not meeting. You have 7 days to do it, like always. Now, on the 7th, I won't be here, don't show up. We won't be here. Yes, whoops.
Can I do it like when I get home today? The Unit 2 test?
You can do it anytime between noon. It's always noon, the day of the last lesson is when they open, and then they close at 8 a.m. the day of lesson.
So I'm going to Ohio
So-
during.
Cool. That sounds like fun. So yes, you can do it early. Do them early if you're ready. Absolutely. So virtual class on the 7th. Wait, don't start packing up because I want to make sure that, I mean, you don't leave for a bit. So, I mean, pack up your lunch, but don't start like, I'm going to leave because we got to cover some stuff still. So this one is going to be a little tricky. So Jack, be sure you pay attention to this because you're a team captain. Who else? Drew, James, Alex. Okay. So the way this is going to work is on the 4th, we have a virtual class. And we also have this independent lab, but it's actually like a virtual lab. So the class you can do anytime. It's open, so you can go in, it's a video, you go in and watch the video class, right? You can go in and do the class, and there's homework for it and everything like always. There's just, you won't be standing here. It's a lesson like this, okay? Up there without me, oh, you can do it. Now the lab, this is where it gets tricky. So this is where team captains need to kind of focus for a minute. So the way this is gonna work is there is a lab in your binder. So if you have your binder and you flip, you'll see there's a lab for next week that says it's about soil types and climate. All of you need to do that lab. It's a paper lab. You don't need to have anything. You just read the data. And you need to do that before 11 a.m. on the 4th. Because at 11 a.m. on the 4th, you're gonna go to the assignment in Teacheries and click the link, and you're going to a Zoom, and there is everybody. And there is a poll in the Zoom, okay? And you go to the poll first. There's instructions that tell you all of this. You go to the poll first, and the poll says, basically, it's all the questions from the lab you just wrote down in your binder, okay? And you're gonna answer the questions based on what you did. So you've done your work beforehand, so based on what you did, you're gonna answer the questions, and then you're gonna go to a breakout room with the rest of your team. This is all through Zoom, and it's all set up all virtually. So you're gonna go in the breakout room, and as a team, you're gonna decide which answers you're putting forth by looking at the polling data. You can see maybe your answers weren't the same as everybody else's, but a lot of people are saying it's multiple choice. So a lot of people are saying A is the right answer. And 3 of us said C, but the rest of the group said A. You got to decide, are they right or you right? So you're gonna then, your team captain, you're gonna take that conversation that you just had with your team in the breakout room, and you're going to hit a little link that's there and zip over to a Google form. The Google form is where you're gonna put your team's answers. And that's where your team answers are coming in. So you're gonna get credit for the poll that you participate in, and then for the final Google form that's submitted. So when you go into your assignment for this lab and click it, it's gonna take you to our website, and there's a link on our website that's not a visible link, meaning if you just go to the website and look for it, you cannot find it. You have to go through our gradebook. You have to go through Teacheries to get to it. And it's all set up, and it's got like your team name and a little click here, and all the instructions are there. So that's what you're going to be doing. And there's also instructions on how to do that in the lesson for lesson 7 too. So you can, if you want to get, watch it early and see that, you can. So that's going to be for that. The 8th now, this is virtual class, just like this, no lab required, but if you do it, it's extra credit. And it's a paper lab that you will have to turn in when you come back to class. So if you want that extra credit, that's how you do it. Also, I was asked about extra credit for the test. Like if you do the standard extra credit assignment for the unit test, you can email me those answers, okay? Lesson 9, we're coming back, and you're gonna get your Q2 packet because we're already there. Oh my goodness. And then lesson 10 is our last day of the first quarter. And it'll be November, and we'll be in the second quarter. So, this is coming. Okay, it's almost October. somebody who's been here. What are we celebrating? What are we celebrating? Lily, what's Tinker Day, my friend?
Tinker Day is the day that at your college where you come to school in your pajamas and eat Krispy Kreme donuts.
That's pretty much, it's a lot of it.
Then
Anything
hike up the
else?
Mountain.
Any, hike the
And
mountain.
hike them out.
Okay, what college? Ooh, yes, some people are gonna get disowned. Andrew,
Collins.
thank you, sir. So, okay,
That's
So,
not fair.
yeah,
You just described my,
Dream Day.
yeah.
It kind of is.
Donut.
it kind of is. So Tinker Day is a Holland's tradition only. It's nowhere else. You can't go out anywhere else in the world to get Tinker Day, which is a shame. So Holland's is, that's where I went to school. It was Holland's College when I went there. Now it's Holland's University. Nothing changed. It just changed the name. It was dumb. But anyway, it's been going on since the late 1800s, long time. And yeah, very long time. And the college president picks a day in October, but she doesn't tell anybody when that day is ever. It's a secret until she wakes up that morning and calls the dean of students, who calls one designated senior student, who then calls her helper, and they go ring the chapel bells. That's the chapel. You can see the bells in it, right? Now, these are bells. You ever seen like Hunchback of Notre Dame, like Quasimodo, where you ring the bell with the giant rope and you got to get it going and then you hold on and it takes you up in the air? Those kind of bells, big bells. They're really cool. And that wakes the whole campus up at 6 a.m. and it's Tinker Day. And that means no classes. No classes for the day. If you had a test, oh, well, it's canceled for the day. It moved just another. It's great. You don't even bother to get dressed. It's all women's. Nobody cares anyway. You walk in your jammies. Everybody goes in their jammies. Nobody bothers to get dressed. You go down to the cafeteria and they have fresh delivered Krispy Kreme donuts. I'm talking tens of dozens of fresh, hot, gooey Krispy Kreme donuts.
Yeah.
But you eat fast because you have to go back to your dorm room. What do?
Hike them out.
Before that?
Get ready to green and gold.
Green and gold's one of them.
Dressed up funky.
Yeah, dressed up funky. Yeah, okay. So people plan for, well, pretty much all of the semester and even into the year before Tinker Day outfits. So the weirder, the better, the crazier, the better. Yeah. And then you meet on the front quad and the president makes this goofy little speech about how it's Tinker Day. It's always the same goofy little speech. It's a proclamation, official proclamation. And then the entire campus hikes from over here, where the quad is, all the way down this road and up this mountain to here. It's a heck of a hike. And when you picture women in the late 1800s doing this in wool skirts and leather shoes with leather soles with heels, it's a heck of a hike. It's impressive. Yeah.
How long has Krispy Kreme been open?
I don't know if Krispy Kreme's been part of it forever. That's developed probably more recently. Yeah, but the hiking up the mountain and the canceling the classes, there used to be two. There used to be one in the fall, one in the spring. The reason it's called Tinker Day is that this is Tinker Mountain. And there's a lot of conquer the mountain. And the symbolism behind it is, you know, you've climbed a mountain, you've made it to the top, you've conquered something difficult. And along the way, maybe your friends have to help you. I've got pictures of girls reaching down and pulling other girls. One of the most famous pictures is one of the late 1800s one. And it's these women walking up this like rock face. I mean, it's straight up rock. There's no dirt. It's like this. And they're wool skirts, heels, and the whole deal. And one's pulling the other one up. And so it's like, if you can conquer the mountain, that's a goal. You can do it. That's the idea, especially at a women's college where back in the late 1800s, that was a pretty big deal, you know, to conquer things, to meet your goals. So what we do for Tinker Day is going to be here in your email. You have to go to your email and actually read it, but there are lots of extra credit opportunities, things you can do to get big extra credit. Now, I will go to the forum when it's Tinker Day and the world will know because it's going to be in the forum. I'm going to send out an announcement. Well, it's Tinker Day. Everybody will know. There's no way to not know. And if you are prepared, you can get some extra credit. If Tinker Day falls on a Tuesday, we can't cancel class, but I promise you will have donuts.
Yeah.
And whatever Tuesday follows Tinker Day, you will have donuts. So it will be fun. And you can get extra credit either way. So be prepared for that. Now your Unit 2 test is coming, friends. It's this week. These are your topics. Where do you go to find your study topics? Where do you go?
Forms.
Yeah, in where? In forms?
Study guide.
Study guide is one. Yeah, where do you go? Like, where'd you look online? Oh, Caitlin. Student Dropbox. What file in there are we looking for? Where are you going to find it? It's in a bigger file that says resources, right? Okay. So you're going to go to your Dropbox. You're gonna go to the little thing that says resources, and there'll be a whole thing in there that says Unit 2, and it'll be under your class. There's one for the other guys too. There's also a whole page, it's just a Word document, so that you can click on it more easily. Sometimes PDFs are difficult with some people's browsers or whatever, but you can go in that one, and you can follow every link for every video we've shown in class. They're all there. So if you need to review a video because you learn better that way, it's all there. So these are all the topics. And there's some things in the past that I told you you should always know. They may show up, so keep them in mind. But they always show up on midterms and whatnot. They may even show up sooner. So yes, so these are your topics. So you're going to want to be sure that you study these things and go into your into that resources thing. You'll find this. You'll also find every single slideshow from every lesson in Unit 2. So it's all right there. Everything's right there. If you have a question, tell me, when's the test due? When's it due? Yep, that's next week, right? So you have, like normal, a week. All right, so those are your answers. All right, so you can go back and watch this. Now, wait a minute, we still have to check on this test tube. So let's see what we've got. Now, I'll bring it to you. You don't have to get up.
I want to get up.
So, see, that's
And I was like, dog.
do a whole lot. What a bummer. No. No, it is a little, not a whole lot. No, you know what happened? Oh, this is very interesting. I'm gonna have to put more water in this and do it again. No, so what happened here is it was probably doing quite well because it's reduced its volume a fair amount. But as the water reduced volume, which it did here, it made a lot of water vapor, which fell in here and melted. And you have the lovely salt crystals we had on the edge because they help us all that things. So I'm going to do it again. I will heat it up for you so that I can take a picture and post it because it'll be cool when it's done. And then you have a few minutes. So does anybody have questions that haven't been answered with regard to the upcoming exams or anything else? I mean, tests or anything else? No, we're good. We're good. We're good. Everybody knows where to find everything. Get your money. It's gonna take you 10 minutes to get out the door anyway. So breaking up stuff over there.
Yeah, that's good.
Right.
Dang Bailey, you got a lot of coins.
Yeah, today.
I only remember failing after my couple questions.
There, your friend does. Nice. Sure. Yes, of course, you're using two time yours. Yes, he's spoiled. I love it. He is so spoiled by y'all. Hilarious. And he has no shame about it. So. No shame, Abby. No shame. He does not care. Shame on him. Shame on you, Ozzy. Shame on you. Shame on you, Ozzy. We don't have. Really? Yeah, so just how it happened that our family vacation lines up with fall break. So we are going to notes. Oh, I'm so excited. Where my mom's dad is from. And I've been, you know, as a kid, I went a couple times. My mom obviously went during her life when I was a kid, but Jason and boys have never been. And it's really cool. We're going to do a whole Cape Breton, and that's going to be at Peak Sleep. Hey guys, keep the volume down over there. Remember that's where it's loud, that's for upstairs, okay? So we're also humans. Oh, that is cute. We have a cute. Yeah. Oh, what is this? Dingy? No, the same. What are you? Hold on. Look at this. I do have some things to return, y'all. I'll get into real quick before you leave. I almost forgot. Hey, Alex, I've got your rock. Oh, my dad's nurse is calling. Hold on. Hello? Hey, Dr. Chana, how are you?
Great, I'm doing great.
All right, what was the Piper? I have Piper. Okay, sorry. Yes, Dr. John, I'm sorry. Look at all these kids are going out the door and they're all like, "Ugh." Yeah, all right. Yes, yes. Okay. Okay. Yeah, right. Yeah, pretty much. Yep. Paxlovid? Okay. Mm-hmm. Ah. Yeah, yeah. Wow, okay. Okay, okay. Right, right, right. Right, right, right. That's great. Okay, good. Ah, okay. 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 Yeah. Okay. Oh, yeah. He told me his nose ran for 48 hours. Yeah. Okay. Yeah. Okay. Does he need any, he's not at a steroid point, right? Everything's okay for the insurance, nothing that we. Okay, and then, yeah, that's great. Okay, good. And then, where do you stand on the, look, I know a lot of people are doing like a prophylactic antibiotic, but if his lungs are clear, is not needing that. Yeah, okay, his lungs are good, we're good. All right, that's awesome. Yeah, no, our DO when my husband got it, he's like always been a severe asthmatic, and he's like, nope, like everything got called in one time. He's like, we're not playing with you. So yeah, yeah. That's great. Yeah. Yeah, he sounds awful, but I'm glad to hear that his lungs are clear. That's the big deal. Yeah, my sister should be coming back tomorrow from Seattle. Everybody but my brother-in-law. And it's weird. Yeah, and my sister tested on the cruise ship. And so she and my brother-in-law just quarantined in their room. And then she was the last one off the boat. And she's been in a hotel room in Seattle because she's quarantining out. Meanwhile, dad and his girlfriend both knew darn well they probably had it. At least the girlfriend did. And they just wandered around, got on the plane, and we're like, oh my God, what are you doing? So at least he got back, but still, I'm the people that came in contact in time. We probably did it. That's exactly what you're doing. And you have to have a really laid back attitude for your job. Because you've probably got the most non-compliant patient base of anybody on the planet. So. Gotta be worse than your average patient where. Well, all right, I really appreciate. Yeah, I really appreciate you saying it because I was worried because nobody can lay eyes on it since we're all stuck here. And you heard he decided to take himself a food line. So, oh my God, yeah. Yeah, so that was a death wish, which he survived again. So I guess that's what he's meant to do. So. All right, well, I appreciate you calling and letting me know he's okay. You have a really good week. All right, thank you. Okay, bye-bye. Sorry, I had to take that. That's a doctor at my desk. Yes. My sister, my brother-in-law, and my
They just have.
No, yeah. Should get here. That water at 98.1, still not boiling. So close. Goodness. Let's see. Let's make that. Oh, there we go. You know what I'm gonna do? I'm gonna give everybody a better surface area.
So are we gonna talk about it more today?
I gave it to Dad, or I put it on the stairs for you to get to Dad, because he has the information on the account that we need to have when we make the call. Like somebody who's gonna make the call has to be like, so where do I want? You have to be able to access the online account, and I don't think I can do that. Let me see if I can make this go like this. Yeah, you're a good boy. You're my good boy. Huh? You're a good boy. You're my good boy. Yes, you are. You're a sweet boy. What do you think? Sweet boy? Yeah, most of the time. He's all right. We'll keep him. We'll keep him. Huh? Oh, my friend. We'll keep you. Stuck with this young one, well. No. Yes. Okay. Hello. Yep. Okay. Okay. Uh, Okay. Are you serious? That's funny. No, it's just yeah. Yeah. Really?